Okay, so this is the Chapter 8, D-Day number 1, homework, which is the backside. Okay, so this is a synthetic division problem. And again, you want to ask yourself, what makes this x plus 2 0? That is going to be a -2, so I put a -2 here. Now here you want to be careful because this is really x cubed plus 0x squared plus 0x plus 8. I need these two zeros as placeholders. So I'm going to write 1, 0, 0, 8. Again, I'm just doing one synthetic division, so I'm going to do it where I'm going to write what I'm adding every time, okay? So I bring down my first number, 1. 1 times -2 is -2. Add, I get -2. -2 times -2 is 4. I add, I get 4. 4 times -2 is -8. I add, I get 0. So this has a remainder of 0. So that meant that x plus 2 was a factor. It also means that -2 is a solution, okay? If I did not get a 0 here, then that number would not be a solution, okay? This number here would be what I get when I put this number into the polynomial. But in this case, I am just dividing. So my answer, since this was a degree 3, this is now a degree 2, is going to be x squared minus 2x plus 4. That's your answer. They're not asking us to solve. They're not asking us to factor beyond this. They just wanted us to divide. And so when I take x plus 2 divided into this, this is what I get. Okay, on number 10, we're sketching this, okay? So it's here you want to pay attention to degrees. So this is a 0, 2, 1, sorry, 0. This is a 1, 2, 1. So I've got 1, 2, 3, 4. This is a degree 4. It is a negative degree 4. And so all even degrees you can kind of think of as parabolas. So a positive parabola would open up. A negative parabola would open down. So this is not a parabola, but I just want you guys to understand it should be having the same end behavior, should be starting and stopping below the x-axis. Okay, if this had been an odd, odds are going to be like a line, positive line or negative line, depending on if it's a positive or negative. Okay, so now let's look at my x-intercepts here. I'm going to have x equals 0 from here. I'm going to have x equal 3, and that is going to be, I'm going to put times 2 because it's a double, okay? And then I have x equal 1, and here I'm going to put that times 2 in a different color. Okay, so I don't mean we're timesing it actually, whoops. I want us just to understand that that means that we have it twice. So I want to pay attention to how it is here. So 0, 3, and 1. Okay, so now I'm going to draw my graph. I'm not going to scale my y. I'm going to scale my x. So I have a 0 at 0. I have a 0 at 3, but this is going to be special because it is a double, so I have to pay attention to that. And then I have 1 at 1. Now, it should be starting below, ending below. So I am going to start below. It's going to go through this one. It's going to come through this one because this is also a single. And then when it comes to this 3, which was a double, it's going to bounce off like that. And there's your graph. Okay, on 10, we're going to find our zeros. Okay, so I am going to be looking for my P over Q. So here, this is going to help me with my P. There's really a 1 here. That's going to help me with my Q. So since this Q is 1, that's going to be nice because my P over Q's are going to be integers. I'm not going to have fractions. So when I do P over Q, I am taking all the factors of 20 on top. And again, all of these are going to be plus or minus. Factors 21, 2, 4, 5, 10, 20. Okay. Now, again, all factors of 1 are 1. So really, I would be putting all these over 1, but that's just going to give me the same numbers. So I have integers, so I don't need that. Okay. So now I'm going to do my synthetic division. I'm going to have 1, 9, making sure I'm not missing any terms, 24, 20, okay? And I'm going to do it in the kind of the table form because I may not get it right the first time. Okay, now something that you want to pay attention to, okay, and I mentioned this in terms of Descartes' rule of signs. If you look at the signs here, okay, where this is I'm going to do it right above this. This was a positive, 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 positive. I have no sign changes. I am going to have no positive solutions, okay? So I don't need to waste my time trying positive 1, 2, 4, 5, 10, 20. You can also kind of think of it this way. If I'm putting a positive number here and I'm bringing down a positive, timesing positives, adding to a positive, nothing's going to cancel out. So it makes sense that I shouldn't be trying the positives, but some of us might be focusing on trying all the positives. Don't. It's going to be a waste of your time. So I'm going to go the other direction. I'm going to start with negative 1. I'm going to bring that down. So this is a 1. 1 times negative 1 is negative 1. Add it, 8. 8 times negative 1 is negative 8. Add it, and I end up getting a 16. And if I take 16, negative 16, and I add it, I get a 4. So I was at 20, now I'm at 4. I'm going down towards 0, so I'm going the right direction. So let's try negative 2. Bring it down. So again, I'm bringing down the 1. 1 times negative 2 is negative 2. Here, let me do it in a different color so we can just see which lines are what. Okay, so negative 2. I'm bringing down my 1. 1 times negative 2 is negative 2. I add it to the 9, 7. 7 times negative 2 is negative 14. I add it to 24. I get 10. 10 times negative 2 is negative 20. I add it to 20. I get 0. So right now I found a 0. Okay, x equal negative 2. Now always pay attention to the degree. This is degree 3. So I should get 3 answers. This degree 3 means that this is now a degree 2. So this is going to be x squared plus 7x plus 10. I can factor that. So what multiplies to 10 and adds to 7? Well, that is going to be an x plus 5, x plus 2. So my other 2 answers is going to be a negative 5. And you'll notice that I got a negative 2 again. So I actually got negative 2 twice. So I had a double root and then the single root. And those are my answers. So now let's take a look at number 12. Okay, so on number 4, this is number 12, it is a degree 4, so we're going to get 4 solutions. So we're going to have to do synthetic twice. Taking the 4 down to a 3, then taking that, doing synthetic division for that 3 down to a 2, stopping there, writing as a quadratic and solving, okay? Couple things, something I'm just noticing right away. Do you see how all of these are positives? Don't try any negatives. No negatives are going to work. Okay, again, because of Descartes' rule of signs, where you're counting sign changes, and I have no sign changes, so it's not going to have any positive solutions. So I'm going to be looking at my P, which is 9, and my Q, which is 1. Okay, and so this again is nice, at least I don't have any fractions. So when I do my P over Q, it's going to be plus or minus, and all factors of 9 are 1, 3, and 9. And then all factors of 1 are 1. I don't need to put it over 1 because anything over 1 is itself. And I just said that because these are all positives, there's no sign changes by Descartes' rule of signs. I don't need to try any positives, so that's going to be negative. I have 3 choices: negative 1, negative 3, negative 9. Let me put the negative in front of each of them. Okay, and here I'll move this negative, make it look like a negative. Okay, these are the numbers I'm going to try. So I'm going to start with 1, 6, 10, 6, 9. Okay, I'm going to start with negative 1, bring it down 1. 1 times negative 1 is negative 1. I add it, I get 5. 5 times negative 1 is negative 5. I add it to 10, I get 5. 5 times negative 1 is negative 5. I add it to 6, I get 1. 1 times negative 1 is negative 1. I added, I get 8. Okay, that didn't work. Fine, we'll try negative 3. Again, bring down our 1. Here, I'm going to use a different color. Okay, bring down our 1. 1 times negative 3 is negative 3. Add it to 6, I get 3. 3 times negative 3 is negative 9. Add it to 10, I get 1. 1 times negative 3 is negative 3. Add it to 6, I get 3. 3 times negative 3 is negative 9. I add it to 9, I get 0. So I found one of my solutions out of 4, okay? So one of them is going to be x equal negative 3. That's one of my answers. So again, this was a degree 4. This is now a degree 3. I'm going to take this 1, 3, 1, 3, and now I'm going to do my synthetic division again, okay? Now, looking at this new p, it's not new in the sense of adding things on, but 9 is not going to be a factor of it, so I'm not going to be using the 9, okay? Negative 1 didn't work before, it's not going to work again. Neither are those positives that I talked about, so I'm thinking maybe I should try a negative 3 again. Maybe it's a double root. Okay, that's what I'm thinking. So I'm going to try negative 3. I'm going to bring down my 1. 1 times negative 3 is negative 3. I add it, 0. 0 times negative 3 is 0. I add it, 1. 1 times negative 3 is negative 3. I add it, 0. So again, what did I do? Why did I decide not to try that, that 9? Because this is my new p. Now this p is not going to add things on to my choices, but it might take things away. So now my p is 3. Again, I'm not adding anything new, but I don't need to try my 9, okay, because 9 is not going to multiply and get me 3, okay? I don't need to do my negative 1. Why? It didn't work before. So I'm left with just trying that negative 3. And it worked again. So then this gets me x equal negative 3. So I have a double root here. And now I'm left with, again, started with a degree 4. Okay, this was my degree 4. Got a degree 3. Took that degree 3. Now this is a degree 2. So I'm going to write out x squared plus 1 equals 0. I am going to subtract 1, get negative 1. I'm going to take the square root. I get x is equal to, and here's where I'm getting conjugates, plus or minus I. So these are my 4 answers, okay? This is actually going to cross the x-axis once, negative 3. It's a double. It's going to bounce back. These, it's not going to cross, but these will make my answer 0. Okay, so now let's take a look at the next problem. So on a problem like this, I have 3x to the 4th is equal to 48. I'm going to divide both sides by 3, and I get x to the 4th is equal to, and again, when I divide by 3, I'm going to get a 16. Now, for this, I could rewrite this, okay? This really could be an x to the 4th minus 16 equals 0. And then I can factor this, okay? And so this is going to be a difference of 2 squares, x squared plus 4, x squared minus 4. You want to be able to recognize those things, okay? So here, again, that x to the 4th minus 16, it is really just a squared minus b squared equal a plus b, don't need that dot in front of it, a plus b times a minus b, okay? That is really what difference of 2 squares is, okay? And let me just change that color so it's not, okay? So that's the formula for difference of 2 squares, and that's what I have here, a square minus a square. So I get x squared plus 4, x squared minus 4. Now, if you don't do this, you're going to not get all 4 of your solutions. So you want to do it in this type of a format, okay? You want to factor it. So what do I mean by that? Well, here, if I wanted to factor this, okay, I could think of this as, when I say factor, I mean over imaginary. So again, if I have this, a squared plus b squared, this is really a plus bi, a minus bi. So this is going to be x plus 2i, x minus 2i. That's what this is going to factor to, okay? And then the other one, let me grab the pink because I did that one in pink. This one here is just a regular difference of two squares instead of the sum of two squares, which again is imaginary. This is going to be an x plus 2. Let me scooch it a little bit. And so we can see this. And this is going to be an x minus 2 equals 0. So I am going to get x, keep on grabbing that by mistake, sorry. X equal negative 2i, positive 2i, negative 2, positive 2. And here are my 4 solutions. Okay, so you want to recognize that this is a difference of two squares that I can write like this, and I should be getting 4 answers. Okay, number 14. Okay, here we're dealing with logarithms, okay, logarithms. So when you have a logarithm, you want it as a single log, which it is. If it is a single log, you want to rewrite it in exponential form. So the log base 4, your base is 4. Whatever you get when you take the log, that is your exponent. So 4 to the third is equal to 3x minus 1. 4 to the third is going to be a 64 equal 3x minus 1. 65 equals 3x, and x is going to equal you can give it to me as 65 over 3. If you're going to give it to me as a decimal, it's a 21.6 repeating, okay, or a 21.67 if you're going to round. Okay, on number 16, this one is an exponential problem, okay, but we need to get our base to a power by itself first. So I'm going to divide by 3. So I'm going to get 2 to the x is equal to 15. Now 2 to the x equal 15 is not a nice one in the sense that I can not 2 to any nice power is going to be 15. So I'm going to use logarithm. So I'm going to log both sides, okay? So I am going to go and take the log of 2 to the x and the log of 15. And so when I do that, the exponent comes in front, so it's this x log 2 is equal to log 15. I'm going to divide both sides by log 2. So I'm going to take log 15, which I'm doing these base 10, right, over log 2, and I can just put that into my calculator. Okay, and so when I do, I'm just going to sketch this like this. Okay, so when I do, I'm going to do it as a fraction. Okay, so I'm going to take log of 15 over log of 2. Okay, and you can kind of reason through this. 2 to the third is 8, 2 to the fourth is 16, so it should be in between 3 and 4, and you see it is, and it's closer to 4 because it's closer to 16 than it is to 8. So 3.91. Okay, so this is going to be about 3.91. Okay, and the next one, which is the last one, this is a logarithm one, but this one we have more than one log on one side, so you have to get that to be a single logarithm. So when you have a log plus a log, you can multiply, write it as a log of the product of these. So this is going to be log of 4x squared is equal to 2. Now, since there's no base here, this is your common log. It's base 10. So now I'm going to write it in exponential form. 10 to the second, remember this is always your exponent, is equal to 4x squared. So 100 is equal to 4x squared. I am going to divide by 4, so I get 25 is equal to x squared. And then when I take the square root, I take the square root of this, I get x is equal to positive and negative 5. Now, we always need to check for extraneous solutions, okay? And in this one here, I didn't check because this was a positive, and it's not going to make this negative. I should have really checked. This is my answer. Okay. But over here, we definitely need to check. So when I put in these numbers, I can only take log of a positive. I cannot take log of 0, and I cannot take log of a negative. So the 5 is going to work, but the negative 5 isn't. So x equal 5 is going to be an answer, and the x equal negative 5 is not. This is extraneous. Okay. And again, use this video as a help to see and check the ones you don't understand and understand how to do this.